In question 4, we have a diagram that shows a sector ABC of a circle with center A and radius 8. The area of the sector is 16 upon 3 pi, and the point D lies on the arc BC. We have to find the perimeter of the segment BCD. So the perimeter of the segment BCD will be given by the arc BDC. So BDC plus the length of BC. Now to find the arc length BC, we need the angle theta, and for the length of BC as well, we will also be needing the angle theta. So as the area of a sector is given by 1 upon 2 r squared theta, we have been given the area as 16 upon 3 pi. We know that the radius is 8, so this will be 1 upon 2 into 8 squared into theta. Cross multiplying, simplifying, we'll get 32 pi upon 3, and this 8 will divide over here, 8 squared, so this will be 64 is equals to theta. So simplifying this, we'll get theta as 1 upon 6 pi. Now to find the arc length, we'll use the formula. So the arc length of BC will be is equals to r theta. So we know that r is 8 and theta is 1 upon 6 pi. So this will be theta into pi upon 6. Simplifying this will become 4 pi upon 3. To find the length of BC, we can use the cosine rule, as the length of AC is also 8. We have the value of theta, or we can divide this graph into an isosceles triangle, which will become a right angle triangle. So if we make a right angle over here, and if we find the half the length from B till this point, let's say this point is X. So to find this length, this angle will become pi upon 12. So using this as pi upon 12, this will be opposite, and as 8 is the hypotenuse, we can use sine. So using sine of pi upon 12 is equals to the length of bx upon the radius, which is given over here as 8. We'll get, so sine of pi upon 12 will be pi divided by 12, and then we'll multiply the answer by 2. So bx will be 8 into sine of pi upon 12 and times 2, as this was the midpoint, x was the midpoint of BC. So multiplying this answer by 2 in the calculator, the length of bx will be 4.14. Now adding the two lengths, 4 pi upon 3 plus 4.14, we'll get a final answer as 8.33, which will be the perimeter of the segment BDC.